Alright, here's another word problem, and as always we want to start by identifying the variables we know. So the first thing we might notice is that this bridge is 80 meters high, so this rock is going to fall the 80 meters, so that's the displacement. And then it wants to say how long it takes to hit the ground, so we're looking for time. And you might look at that and say, well, that's not a lot of information to give us, and it's not. We actually need more. There are things in this problem that we can infer that are not specifically stated. So the first is the rock is being dropped off the bridge. It's not being thrown. So anytime something is dropped, we're assuming the starting speed is 0 meters per second because it was in your hand, motionless, and then you let go of it. So that tells you VI. Now the other thing is, we're dropping this off a bridge. It doesn't say it, but unless it says otherwise, you can assume that we're on Earth. And if we're on Earth, then we know the acceleration of any object on Earth is going to be, we're going to round and say it's 10 meters per second squared. It's actually 9.8, but for most problems, even the AP, they'll let you get away with 10. One question you might have is, well, is this negative or positive? Well, if we think we're up on the bridge and we're going to drop it down and it's going to be 80 meters, we're going to call the ground 80 meters away and it's going in one direction, it's a lot easier just to say all the numbers are positive. So it's okay if the object's falling to say the acceleration is 10 meters per second squared. Downward, we don't have to worry about positive versus negative here. So that makes things easier. Alright, so we have VI, A, delta x, we're looking for t. So again, we try to find an equation that has all of these variables that does not have VF or our average velocity in it. So again, 1 and 2 are out, they both have average velocity. Equation 3 is out because it has final velocity. Equation 4, if we look at, we know delta x, we know VI, we do not know t, and we know A, so there's enough information here for us to use this equation 4. Equation 5 we can not use because we don't know VF. So we're going to solve this with equation 4. Alright, here's another equation. So same thing, we're going to identify what we know in this situation. So this is a baseball is thrown up into the air at a speed of 20 meters per second. So this is not being dropped. So VI is 20 meters per second. We want to know how much time, so we're looking for t, that's unknown, will it take to return to its original location. So if we're here on the ground and we throw a baseball up in the air, it's going to return to its original location. So delta x is the displacement. So if it starts and ends at the same point, delta x is going to be 0 meters. Now remember, displacement is, again, how far you are from the beginning to the end. It's not how far it traveled. That would be distance. So that's delta x. So now the question is, what is A? So in the last problem, we were able to say A was positive. This one's a little different. We're throwing the ball upward, and we're calling that positive 20 meters per second. However, gravity, we know, pulls objects downward. And so since that's the opposite direction in which the ball was thrown, that means A is going to actually have to be negative 10 meters per second squared. So it was okay to call it positive in the last problem because we were only considering one direction. We called all objects going downward to be positive. So as long as you're consistent, you can define any direction to be positive. But anyway, that's everything we know, and we're looking for time. So we go through our equation, we try to find which of these work. Again, equations 1 and 2 can quickly be discarded because we don't know the average velocity. Equation 3, we don't know VF, so that's out. Equation 4, we know delta x, we know VI, and we know A, and we're looking for t, so that is a valid equation to use. And again, equation 5, if you just want to double check, we don't know VF, so that's out. So this is also an equation 4 type problem. But again, this is the system, this is how you go about solving one of these word problems. It's really just about deciphering the problem, figuring out what it's telling you, and then it's just plugging into the equations. And again, in the next video, we will actually go through and continue and solve the problem. But right now, I just want to really focus on the setup. So, until next time, I am Derek Genova. Have a delightful day.